Hey, today we're going to be talking about writing expressions. We've been talking about expressions for the last little bit, about numerical expressions and algebraic expressions. And today we're going to work on translating from words into an algebraic expression. So here we go. We're starting off with our standards and our I can statements. Hopefully by the end of this you'll be able to translate a relationship given in words into an algebraic expression. You'll be able to identify parts of an algebraic expression by using correct mathematical terminology. You'll be able to recognize when an expression is representing a sum and or difference of terms versus products and quotients, and recognize an expression as both a single value and as two or more terms on which the operation is performed. So those are our goals to reach throughout today's lesson and this week before our test. So translating phrases into sentences, that's always the trickiest part when it comes to word problems. It's easy when the teacher gives it to you in just numbers 3 plus 5, but when we put it into more of a word problem, that's where we tend to get lost. So that's what we're going to be focusing on today. To solve real word problems, you're going to need to translate verbal phrases and sentences into variable expressions and equations. We need to look for keywords that indicate addition, subtraction, multiplication, and division. And so this here happens to be a little bit of a cheat sheet. Anytime we're going to be adding, you might see the words plus, the sum of, increased by, total, more than, added to. All of those things are going to indicate addition. If we need to subtract, we might hear words like minus, a difference of, decreased by, fewer than, less than, subtracted from. A key for multiplication is the words times, the product of, multiplied by, of. That's a big one that we worked on in percents. And then twice. Division, divided by, the quotient of, separate into equal parts. All of those things tend to just help clue us in to the fact that we're going to use those operations. Order is important in subtraction and division. We need to remember that. We've already worked on how in adding and multiplying it doesn't matter the order, but in subtraction and division it sure does. So for example, 2 less than a number would be 2 less than a number. We don't know what that number is, so that's why we have it written here as x, and then 2 less than is x minus 2, not 2 minus a number. We have 2 less than a number, which makes it have to be the number first and then take away the 2. Similarly, a number divided by 5 is written as x divided by 5, not 5 divided by x. So we need to make sure that we're watching out for those little loopholes there. So let's just jump right in. We've got an art show. Your school's art show has X amount of pieces in it. We don't know how many pieces, so we're just going to represent it as X. You expect to add 3 pieces. What will be the total number of pieces in the show? You will see a way to express the total in example 1. So write these phrases as a variable expression. The first phrase is 3 pieces added to X pieces in the art show. So we've got the number in the show, and then we're adding 3 pieces to it. So 3 pieces added to the X. So this is what we started, and we're adding 3 to it. The sum of 4 and a number n. Sum tells us we're going to be adding. The sum of 4 and a number n. So we're going to say 4 plus n. And again, order doesn't matter here because we're adding, so you could have had n plus 4. That's fine. The difference of 12 and a number x. So the difference means subtract. We're going to take 12 and find the difference between 12 and x. And 9 fewer than the number of boys. So that means we need the number of boys minus 12 of them. So notice these ones were a little trickier. Here we had the difference of 12 in a number, so we took 12 minus that number. But then here we had 9 fewer than the number of boys, so we have to make sure that we start out with our boys and then take 9 away. All right, write a phrase as an expression. Let y represent the number So again, here's our phrase, the product of 5 and the number of girls. So product tells us that we're doing, I hope you said multiplication, the product of 5 and the number of girls. So we said y would be our number. So we're just taking 5 times y. I would write it as 5y. 8 multiplied by a number. So again, 8y. 8 multiplied by a number. 8 multiplied by y. So then we have a quotient of a number and 6. So that means we're going to have y divided by 6. Or you could have written that as y over 6. Either one would be the same thing. And 24 divided by the number of hours. So 24 divided by y. Or again, you could add 24 over y. All right. So again, watch the order. Write the phrase as a variable expression. So again, we're just going to do a little bit more practice here. It just takes practice. Take your time with it. Think it through. It'll be fine. So let's go ahead and look. 16 decreased by a number d. So what do you think we're going to be doing there if we're decreasing from 16 by this number? We're going to be doing 16 minus d. Decrease means minus. I'm going to let you guys do this side on your own. We'll work through this side together here. So you're going to be doing the evens in your homework. I'm going to be doing the odds with you here. So now we have a number h increased by 15. Increased is going to mean addition. So we'll have h plus 15. 4 fewer than a number g. So 4 less than a number, 4 fewer than. That means I've got to start out with my g and subtract 4. And then write the Frisian expression. We're going to use x this time. 25 divided by the number of inches. So 25 divided by x inches. I want you to go ahead and try these even ones on your own. We'll go ahead and check them tomorrow in class. Good luck, be patient, and try your best.